All right, welcome back. We are on 10.4, P178, the homework, the backside of the homework for Chapter 10, Lesson 4. All right, it's number 1 says, write a capital letter that appears to have perpendicular line segments. So it's got to be a capital letter, and it needs perpendicular line segments. So the letter that immediately comes to mind for me is H. If we draw a capital H, you can see that these lines intersect to form 90-degree angles. So those would be perpendicular. But there are other capital letters that would work as well. F would work, for example, because you create the 90-degree angles on the inside. And I'm sure there are others as well. So any capital letter that you come up with that forms a 90-degree angle is going to be acceptable. In the figure, which pair of line segments appear to be parallel? So again, parallel, two lines that will never intersect if they continue on. So we have line segment FJ, but if we continued FJ on, it would eventually intersect with GH, line segment GH. So those two are not going to be parallel. Line segment FG, if it were to continue on in both directions, would never intersect with line segment JH if it continued on in both directions. So, which pair of line segments appear to be parallel? Line segment FG is parallel to line segment JH. And that's how we would write that out. Line segment FG parallel to line segment JH. All right, looking at number 3, Nolan drew a right triangle. How many acute angles did he draw? Well, again, the best way to do that is just to draw a right triangle ourselves. So I'm going to draw a triangle that has a 90-degree angle because that's what makes it a right triangle. It has to have that right angle in it. And then I'm going to close that triangle off. And how many acute angles? Well, there's the right angle. This angle is acute. And this angle is acute. So it has 2 acute angles. All right, number 4, Mike drank more than half. So he drank more than half the juice in his glass. What fraction of the juice could Mike have drunk? So as long as Mike, well, let's show that Mike drank more than half. So the fraction that we're going to draw, the fraction that we're going to write, has to be greater than 1/2. And it can be any fraction we want as long as it's greater than 1/2. So we could do 2/3 would be bigger than 1/2. That would be a correct answer. We could do 4/5 if we wanted to. So again, any fraction you want as long as it's greater than 1/2. Okay, Mike drank, oh, excuse me, that wouldn't actually be Mike. This side would be what Mike drank, right? So but our answer again, how much Mike drank? He drank more than 1/2. So our fraction has to be greater than the 1/2. All right, number 5, a school principal ordered 1,000 pencils. He gave an equal number to each of his 7 teachers until he had given out as many as possible. How many pencils were left? So again, this is equal number to each. That tells us that we're going to be doing some division. And we have 1,000 pencils that we need to divide amongst 7 teachers. So again, a lot of different ways we can do this. We could do repeated subtraction. We could draw a picture and model the 7 teachers. and then start giving them pencils. I would probably start with 100. If you're going to do that, you don't want to do 1,000 little dots, but you could do, you know, okay, let's start with giving each teacher 100 pencils. That would be 700 of the pencils. So then there would only be 300 left. And then let's see, could I give each one 50, 50, 100, 150, 200, 250, 300, not quite, but I could give each one of them 40 probably, and then I could go through, give them all 40 and subtract that. So again, a lot of different ways to do this. Let's do it the typical long division way though as well, because that's another strategy that we can use obviously. 7 goes into the 1 no times, it can't go into 1. 7 can go into the 10 if we're looking at this as 10 hundreds. It can go in 1 time. 1 times 7 is 7. Subtract gives me 3. Bring down the 0. 7 goes into 30 now. Excuse me. 4 times. 4 times 7 is 28. Subtract gives me 2. Bring down. 7 goes into 20 2 times. 2 times 7 is 14. Subtract gives me 6. So I have a remainder of 6. So how many pencils are left? 6 pencils. Okay, moving on to number 6. A carton of juice contains 64 ounces. Miss Wilson bought 6 cartons of juice. How many ounces of juice did she buy? So this problem is a multiplication problem. So 1 carton has 64 ounces, and she's buying 6 of those cartons. So again, I could make a model to show those 6 cartons. Each one is 64 ounces. And I remember multiplication is just repeated addition. So if I wanted, I could just add all of these 64s together and then see what I got as my answer. But a quicker way to do that, to do repeated addition, is to turn it into that multiplication problem. So I have the number 64, and I have it 1, 2, 3, 4, 5, 6 times. 6 times 4 is 24. Carry my 2. 6 times 6 is 36, plus 2 is 38. Oops. So, how many ounces of juice did she buy? 384 ounces. All right, thanks again for tuning in, and I'll see you on the next one.